present the project called Flashloan. The topic that we will cover today: what is Flashloan, how does it work, implement using Solidity, and the benefit, and also the Flashloan attack. So I will introduce myself first. I'm Patkamon Awaiwanon, the fourth year SKE student. I asked ChatGPT about what is Flashloan, and it gave me this answer. Technically, Flashloan is a cryptocurrency loan that allows borrower to borrow assets from lending platforms such as DeFi without providing any collateral, as long as the borrowed funds are returned within a single transaction. So, to be in short, Flashloan, Flash is mean เกิดขึ้นกระทันหัน and loan is mean เงินกู้ so it just means that you can borrow money immediately. So to give you more understand of it, I'll provide you an example in real world situation. If you want to get some money, you want to borrow some money, you need to go to the bank, right? And the bank then make you to sign the contract. This contract will say that how long you need to pay this money back in this period of time. So let's say 3 years. In this 3 years, you need to return all the money that you borrow back. And the second thing, it will limit the amount. So let's say you want to borrow 100 million baht today in the bank. The bank probably don't give you that because it will measure by your credit. How famous is you? How rich is you? If you have a lot of credit, you can borrow a lot of money, right? Okay, so we will compare it with in the crypto world or in the Flashloan protocol. Instead of we use borrow from bank, right? Real world situation. In Flashloan, we will borrow from the Aave protocol, which is DeFi protocol on the blockchain. And instead of we borrow the cash, we now borrow the crypto assets, which is Bitcoin or Ethereum or any other crypto asset. And instead of solid paper contract, like we now have the smart contract. With this smart contract, we can now borrow a infinite amount of asset that you want. So you can borrow 10,000 billion of Bitcoin. If Aave have that amount, you can borrow all of that. But the limit is now that you have to return back in just 15 seconds. This number will be very depends on the blockchain that you use, because this number is determined that how long one transaction are. So the number of the time of transaction is depend on each blockchain you use. So next, you probably wonder how can you allow an anonymous person to borrow an infinite amount of your money. This will be included in the next topic. How does it work? With ACID property of database. The main one that we will focus on is atomicity. This is the overall architecture of Flashloan. So first, you need to have your own contract that will have a function to call the Flashloan contract from the DeFi protocol or Aave in this case. And this contract then call their own contracts. It will send you the amount of the asset that you specify in your function. After that, they will also call back to another function of you that's named execute operation. In this function, you will have to write your own logic to about what you would do with the amount of money they send to you. And after the end of this function, they're going to send back the money from your contract back to the Flashloan. So with the property of atomicity, if any part of this is error or fail, then it's going to roll back or revert the state of the contract like it's never happened before. So you can say that they will guarantee 100% that the Flashloan will get their money back all the time. Okay, this is the glimpse of code. The glimpse of code, which is to contain two functions. First, Flashloan, which this function are going to call the Flashloan contact from array. And another function, execute operation, the function that the Flashloan contact will call back to us. So yes. Okay, in this topic, implement using Solidity, we're going to move on from this slide to the Linux website to show you the real smart contract writing in Solidity. So if you want to follow this, I will give you the GitHub git contain all the code. Okay, so let's go. This part, we're going to skip all the first part because it's just the interface that told the smart contract what to look on in the function. So this is all the interface. And the real thing on here, the contact Flashloan, which is implemented from Flashloan receiver base. This just to tell the Flashloan array that okay, what to look on this contract. And this is the variable we're going to declare. This is like the initial function, or the function that going to trigger at the first time we run this contract. So just we're going to give them the address of provider of the array. You can get this address from the array document. Okay, so let's go see the real important function, which is test Flashloan and the execute operation. So this function, I already said from the previous topic that this function we're going to describe the logic to call the Flashloan contact. So first, to call their Flashloan contact, we have to run this function, and this function take this parameter. So we're going to write that. So the receiver, which is the address of the wallet that going to take the money. So we're going to set it to be this or this contract. And then the asset, we're going to give them the we're going to specify what asset we want. So we're going to pass this by our own, and this is the amount that we're going to lend from the Flashloan. Also the mode, this is just the high depth of the complex of the Flashloan, but to keep it basic, we're just going to use the zero, which is tell them that we're going to return all the money back in the end of the function. We're not going to make any debt here. And this address on behalf of is just told them that if we will have debt, who will pay this debt. But of course we don't have the debt, so this is not significant here. And also this just an extra config for the high level of Flashloan, but we're not gonna talk about it here. We pass all the parameter we get to this function, and what they do is that we're going to call to the Flashloan array and give this all parameter to them. So they're going to give us back this asset on this amount. So let's back to the architecture of Flashloan. This is just the function that we're going to call to the Flashloan context. This function is here. Okay. And what next is that after we call this function, they're going to trigger the Flashloan attack, Flashloan contract, sorry, and also they're going to give us back the money, and they're going to call back our execute operation function, which is here. And in this function, we're going to constrain the logics that we're going to do with the money. But of course, we're not going to do anything here, so we're just going to emit a lock, or you can think of it like console lock or something like that. We're going to print out that, okay, what are the borrow that we get, the borrow amount that we get, and we're going to lock the fees, or the amount that we have to pay to borrow this amount of money. Okay, so, and also we're going to approve. Okay, so what we're going to approve here is that we're going to approve this contract to be able to get the money back, because in the smart contract anyone cannot just go into another contract and get the money from that, right? We need to give the permission first, so we approve that, okay, this Aave protocol can subtract our money to them, and then we return true, which is Aave will know that, okay, if you return true, then we're going to subtract the money back. So in the end of this function, Aave will get the money that they let us lend back to them. So okay, if you're ready, you just deploy. I already deploy one on the Matrix testnet here. Okay, it's just testnet, so this money is not real, don't worry. Okay, and the asset that we're going to borrow today is the Buildmatic or Wrapmatic here. So first, if this contact you just deploy, you will need to give the Buildmatic backs. You will need to send the Buildmatic or your asset that you're going to borrow to this contract that you deploy. Just a little bit, like maybe just 5% or 1% of the amount that you're going to borrow, and then you specify the amount that you're going to borrow here. So you probably wonder what is this, why the number is too high, because in the DeFi or blockchain world, this number is just mean 2 ethers. Okay, because they have like 18 decimal here. So in this case, we're going to borrow like 10 or 10 the Buildmatics here, 10 the Buildmatics, and then we're going to press transact to run this function. Okay, this is the transaction fee that we're going to have to pay. Okay, and let's wait for a while. Okay, so after it finished, we can go see on the block explorer, and we can see it up on the logs here. It's going to tell that the borrow that we specify on the contract here. We tell them that, okay, emit the lock borrow, and the amount is 10 ether. Okay, so let's check if we got 10 ether or not. Here 10 ether, and the fee that we have paid for this 10 ether is here 0.009. We lose this amount of money to have to be able to loan the 10 ethers, which is very contradict amount. Okay, so this is all. Let's get back to the slide. Okay, the last topic today is the benefit and the flash loan attack. So the benefit of flash loan is that there no collateral required, low cost, and also no credit score required. Okay, we get back to this slide. Remember in the first topic we say that to borrow you got infinite amount, right? And you have around 50 seconds or the allowed one transaction time to repay the debt that you have. So what can you do in just 15 seconds or around one transaction? So we're going to give you the example of this. So let's say they have in this world they have two stores, store A and store B. The store A sell the banana, 2 banana for 1 coin, and store B sell the banana for 1 coin for 1 banana. This number are created by the demand and supply. So you can see that in the store A, banana is cheaper than in store B. Maybe because people not usually go to buy banana in the store A. So in store A they have a lot of supply and they have less demand. So this banana gets cheaper. While store B, banana is expensive. Maybe because a lot of people demand the banana in store B, or maybe store B have less supply of the banana. So what you can do is that you can first you can get the money, right? You can buy banana. You can spend 1 coin and you get 2 banana, and you go to the store B and you sell this 2 banana and you got 2 coin. So you will end up with a profit of 1 coin, right? So this is called arbitrage trading. So we can change from this store in real world into this store in the blockchain world, and you can just what you can do with this flash loan is just you can find this 2 market that have different number of price, and you can use flash loan to get the money and make the profit of this different price. And the last one is flash loan attack. So what the flash loan attack can do, there are various forms of flash loan attack, but the simple one that easy to understand is that the price manipulate, which demand and supply. So you can see that if you see that in this time we have one store, not related to A and B store, just new store, with the price that a banana 1 coin for 2 banana. What you can do is that you with the flash loan attack you can flash loan to get 1,000 coin, and you can buy all of this. You can buy all of the banana. So after that in this store the price turned out to be 1 banana per 100 coin, because this coin is represent the demand, right? So if you just storm all the demand here down right here, the price is just broken, because let's say normally there are 50 person who want banana every day, but out of nowhere you gather all right 100,000 people to come here to buy banana. The price of the banana is just changes rapidly, or you can say that the price manipulate. So what you can do is that in this situation there may be a hacker or maybe someone who want to destroy this store, so they just flash loan the high amount of money and storm this this demand here to make the price is broken. Right now you're going to see that one banana for 100 coin, the price is now messed up because this demand are higher than supply. And there another Flashloan attack that happened in the real life of blockchain. We have 3 examples. The Euler Finance losing around 100 almost 200 million in March 2020, and the Cream Finance losing around 130 million on October 2021, and the BZX losing around 1 million in November 2021. This is all the case that's happened from Flashloan attack. Okay, thank you for listening our Flashloan presentation.